In our last video, we looked at when statements are always true. Now we'll look at when they're never true. So if we have a statement like 22 equals 17, we know it's never true because that just doesn't make any sense. 22 can't equal 17, 17 can't equal 22. So what about the statement x plus 3 equals x minus 5? Well, we can kind of see that this is never true. So if we go ahead and prove it, if we subtract 3 from both sides to get x by itself on the left side, we have x equals x minus 8. But this can't be true because it violates the subtraction property of equality. We can't subtract 8 on one side without doing it on the other and have both sides be equal. So if you flip over the page, now we have the statement 6x minus 2 equals 4 times x plus 3. Well, this is never true, but it's definitely not easy to see on its own. So we need to go ahead and prove it. So if we go through and we add 2 to both sides, get 6x equals 4x plus 14. To get x all by itself on the left side, we divide it by 6. Okay, sorry I had to pause. So I might repeat myself, but it looks like we were proving that statement is not true. So I added 2 to both sides, got 6x equals 4x plus 14, and then divide it by 6 to get my x by itself on the left side, which left me with x equals 2/3 x plus 7/3. And we can't have this because it violates both the multiplication and addition properties of equality. We can't do stuff to an x on one side and not the other, and have them still be equal. So then, for the when it's sometimes true, and these are the problems that you're used to where we're solving for x. These are statements where the answer is not necessarily always or never true. There's specific solutions that will make the statement true. So in this case of x plus 5 equals 9, it's only true when x is equal to 4. So let's take a look at the statement 3x plus 4 equals 13 and figure out when it's true. Sometimes this might be worded as solve for x, or you might have a question that says which values for x will make this a true statement. So let's show how we know, basically just showing our work. So we have 3x plus 4 equals 13. To start getting x by itself, we subtract 4 from both sides, and we get 3x equals 9, and then we divide by 3 on both sides to get x equals 3. So when x is 3, the statement is true, but when x is anything that's not 3, the statement is false. So let's try another one. We have negative 3/5 x plus 8 equals 23. So again, we're going to solve for x, which we've been practicing quite a bit this week. First, we need to subtract 8 from both sides, which gives us negative 3/5 x equals 15. And whenever we have a fraction in front of our variable, to get rid of it, we just multiply both sides by the reciprocal of that fraction. It's basically the fraction flipped over. So now, instead of negative 3/5, the reciprocal is negative 5/3. When you multiply those together, you get 1, which we don't write when we have in front of a variable. So we get x equals negative 25. It's 15 times negative 5/3 is negative 25. So when x is negative 25, the statement's true. But when it's anything else, the statement would be false. So getting tricky, what is the statement of x squared plus 8 equals 17? So when is that statement true? Well, we have a square, so that should tip us off that we may have more than one solution. So we start with subtracting 8 from both sides, and we get x squared equals 9. When we have an x squared equals something, to figure out what x is, we need to do the square root of both sides. So the square root of x squared is x, and then the square root of 9 is positive and negative 3. So when x is 3 and when x is negative 3, the statement is true. But if x is anything besides positive or negative 3, then it's false.